Welcome back to part 3 of Trig 1.6 or Pre-Calc 4.6 notes. Concept for this video is graphing secant and cosecant functions. When we graph a secant function, what we have to remember is that we really are going to graph a cosine graph, and then we're going to draw some vertical asymptotes on our graphs, and then draw the secant graph. So if I asked you to draw the secant graph, the first thing you'd want to do is actually make the graph of the cosine. And that's what this is already on here for you. So this is the graph of the cosine, y equals cosine of theta or y equals cosine of x. And what I want to do is recognize that wherever the cosine graph is equal to 0, that's where the secant is going to be undefined. Because basically what I'm looking at here is for reciprocals. Wherever this cosine of theta or x is equal to 0, I'm going to get 1 over 0. Because remember, secant is the same as 1 over cosine. So that means that my graph is going to be undefined wherever the graph is equal to 0. In other words, at all of these points right here. Cosine is equal to 0 here, 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 and here. So what you want to do is you want to draw vertical asymptotes at those points. Again, you graph the cosine graph first. Then you go through and you draw your vertical asymptotes wherever the graph is equal to 0. And then, so let me grab a different color here. Then what you'll do is you will draw, for example, if the graph between these two vertical asymptotes goes up like this, you reflect it. So it goes up like that. And then down here, the graph is below the x-axis, so and it's going down like this, so you make the reflection go like that. This one would be a reflection that goes up. This one would be down, up, and down. And I could finish this one off. This would just be part of one, and this would just be part of one. So actually the green graph is the secant graph, but I'm using the cosine graph to be able to get that. So we're going to draw vertical asymptotes wherever the graph is equal to 0, where cosine is equal to 0. In this case, that was all those red dots that I put there. And then like you'll see here, it says the secant graph is trapped between the vertical asymptotes. So each of the vertical asymptotes gets the secant graph. So the cosine, or the cosecant graph is going to be the same thing. You'd want to start with the sine graph, and that's what I have down here. This pink graph is the sine graph. And what we'll do, again, is we'll put dots on the graph wherever it is touching the x-axis, in other words, where it's equal to 0, because that's where I want to draw my vertical asymptotes at. And then what I'll do is I'll do the reflection here. So this one would be down, this part would be up, up, down, up, down, up, and down. And so that's what and this part would just be up on the side here. So that's what the secant, or the cosecant graph would look like. It's a reflection basically of the sine graph. And so we want to draw vertical asymptotes wherever the sine is equal to 0. So if I ask you to draw the 2 secant of 2x, what you really want to graph is you want to graph 2 cosine of 2x first, and then you can go ahead and do your secant graph afterwards. So we have to remember the formulas for amplitude. It's absolute value of a, 2 pi over b is the period, c over b, and d. So as I look at this, my a value is 2, my b value is 2, and I don't have a c or a d value. So I know I'm going to get no phase shift and no vertical shift. Amplitude is 2, so my graph is going to go up to 2 and down to 2. My period is 2 pi over 2, which is just pi. So as I think about this, to be able to get my numbers on the graph here, I want to take my period and divide it by 4. So pi over 4 would be each of the increments. So we start off at 0, and then I go over here to pi over 4. Then to pi over 4, I add pi over 4. So pi over 4 plus pi over 4 would be pi over 2. Then I add pi over 4 to that, so 1/2 plus 1/4 is 3/4. And then I add pi over 4 to that, so 3/4 plus 1/4 is 1. And then what I'll do is recognize that the cosine graph starts at the top of the amplitude. So my graph is going to start here, come down to the next one, down here, up, and up. And that will be the cosine graph. So this graph is actually starting at 0, 2, and it's ending at 0, no, not 0 anymore, pi 2. To get my next period, what I'm going to do is I'm going to work backwards. So I'm going to start subtracting pi over 4. So this would make negative pi over 4, negative pi over 2, negative 3 pi over 4, and then finally negative pi. So if I continue the pattern, it's going to look like this. So once I have that, what I want to do now is take my vertical asymptotes wherever the cosine is equal to 0. And the cosine is going to be equal to 0 here, 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 and here. So now you can actually draw the secant graph, which I'll do in green here. So this is what the secant graph would look like. This part would come up, this part would go down, this part would come up, this part would go down, and this part would be up like that. Again, the green graph is the actual answer, but I need the blue graph to help me get to the green graph. So when you're doing these for homework, please use 2 different colors when you're doing it so I know what you're telling me is the secant graph. So now let's deal with a cosecant one. I'm going to rewrite this as 2 sine of, let's see, this would be pi over 2 times x minus pi over 2. Because that's really what I'm going to graph, is the sine graph. So my a, my 2 pi over b, my c over b, and then my d. So looking at this one, my a value is 2, my b value is pi over 2, my c value is also pi over 2, and I don't have a d. So the amplitude would be 2, my period would be 2 pi over 2. So when I do that, if I get rid of this by timesing by the reciprocal, 2 over pi, the pi's will cancel out. I just have 2 times 2, which is 4. So I don't have any more pi's left in my period. My phase shift would be c, pi over 2, divided by b, pi over 2, which is just going to be 1. And because it's a positive 1, that means I'm going to shift to the right. So I like to sometimes write down the direction. And I'm going to have no vertical shift because there is no b, no d value. So normally the sine would start at the x-axis here, but it would come up. So it start at 0, 0 and go up, but because of the phase shift, it's going to start here at 1. So my first dot would be right here at 1, 0. And then what I have to do to get the next ones is take my period and divide by 4. So 4 divided by 4 is 1. So the next one, if I add 1 to that, would be 2, then 3, then 4, and then 5. So that would give me my 4 sections. So I'm going to go up to 2, I'll go down to negative 2, and I'll start my pattern. Up to the top, down, down, back up. If I make this go backwards, subtracting 1 now, I'd get to 0. Then I'd get to negative 1, negative 2, negative 3. So my pattern would go to 0, then back up to the middle, all the way up to the top, back down to the middle. So the blue graph is going to be my sine graph. Now what I need to do is draw in my vertical asymptotes at wherever the graph is touching 0 here. That way I can now make my cosecant graph, which would just be this part here I'd go down for this one. I'd come up for this one. And I would go down for this one. And again, that green graph is the actual graph. So if I finished the rest of this off, I said that it was ending if it started here. The first period ended here at the point 50, and the vertical asymptotes were occurring wherever the sign was equal to 0.